In today's session, we will discuss about 8255. In 8255, futures, control word and the mode of operations will be discussed. 8255 is a programmable peripheral interface. It is derived from the 8155. In the previous class, we have discussed 8155 which have the IO ports and a timer. For in future applications, the requirement of IO ports and the timer is increased. So, it has divided as two separate ICs, one is for timer, another one for IO operations. So, for the timer they are using 8254, for the IO operations they were used the 8255. So, the 8255 is the modified form of 8155. So, in 8155 it have the combination of both IO ports and timer, 8255 only for IO ports and 8253 only for the timer. 8255 is a programmable peripheral interface. It is mainly used for the parallel communications, which also used for interfacing the keyboards, display devices and also for the any output devices like a printer. For interfacing, it has a 24 ports. That ports are grouped named as a port A, port B and port C, which are operated under two groups, group A and group B. The students have to know the full details of 8255, then only he can do any interfacing program. The 8255 also called as a programmable peripheral interface or parallel interface. It is used for general purpose applications. Along with that, it is a very flexible, versatile and economical. We can use it for more number of applications. This diagram shows the pin diagram of 8255. 8255 is a 40 pin IC which is connected in the dual inline package. Dual inline package means in two sides the pins are available. Among the 40 pins, 24 bits or pins are reserved for the 3 8-bit ports. So, 24 ports or pins are available. So, the 3 ports which are named as port A, port B and port C. The number 1 to 4 is port A0 to A3 signals. From 40 to 37, A4 to A7. So, the 8 pins are available on the top of the pin. Then for port B, the signals are available on the bottom. They are from 18 to 25. The pins are available from it is denoted as PB0 to PB7. So, 8 pins for port B and 8 pins for port C, which is available from the pin number 10 to pin number 17. So, totally 10 pins. PC0 to PC3 from 14 to 17, then 13 to 10 it is PC4 to PC7. So, this is a pin arrangement for 3 ports. Then it has 8 data buses which are bidirectional buses, which are denoted as D0 to D7. Here from 34 to 27 the pin numbers D0 to D7 is available. Then it has 2 address lines which are denoted as A0 to A1. The 2 address lines A0 to A1 which is used for decoding and select the port addresses and control register. So, mainly used to provide the port address. Then it has 4 control signals which are read bar, write bar along with that CS bar and reset signal. So, these 4 are control signals. So, the 5th pin is RD bar which is a read operation. When this is active low signal, the bar represents this active low signal. When the pin is low means the processor will read the data from the peripheral device via the 8255. The number 6 is a CS bar which is a chip selector. Chip select which is active low signal which is used to select the IC 8255. The number 36 is connected with the WR bar which is write operation. This is active low signal. When the signal is low means the write operation will be performed. IC pin 35 is named as reset. The reset is one of the control signal which is used to clear the control register. After enabling this key or pin, the control register value will be cleared. So, these 4 are RD bar, WR bar, CS bar and reset. These 4 are the control signal in 8255. Then for every IC have a power supply signal as a 2 pins which is a VCC and ground for providing the DC voltage plus 5 volts. So, the ground pin is connected with the 7th pin, the VCC pin is connected with the 26th pin. So, 8255 is mainly used for the parallel application. It has a 3 8-bit ports, that ports are called as named as port A, port B and port C. It also denoted as PA0 to A7, PB0 to 7 and PC0 to PC7. Then it has a 2 power supply signals VCC and ground. It has a 4 control signals, which is a read bar, write bar, CS and reset signal. Read and write is used for the in and out instructions. CS is used to select the chip and reset to clear the control register. Then it has a 2 address lines, which is used to decode the port addresses along with 8 data lines for data transfer. IO ports. So, the 8255 mainly used for the parallel communication, it is also called as a parallel IO device. So, for the parallel communication, it has a 24 pins are available. The 24 pins is divided as a 3 ports, which are named as port A, port B and port C. The port A and port B is a 8-bit ports. It can be used as a 8-bit port. The port C has divided as a 2 4-bit ports. So, based on our application, either you can use it as a single 8-bit port or 2 4-bit ports, which is denoted as PC0 to PC7. For lower 4-bit ports, PC0 to PC3, for upper ports PC4 to PC7. This diagram shows the functional diagram of 8255. The functional diagram will give the internal blocks which are available in the 8255. So, the first one is data bus buffer. The data bus buffer is used to collect the 8-bit data. The collected data will be stored in the buffer. The pins which are D0 to D7 is available to interface with the processor, which is a bidirectional, because the buses is used for both read and write operation. The next block is read and write control logic. In the read and write control logic, 6 signals are available. The first signal is read bar, which is active low signal, which is connected with the inverter, which is used to perform the read operation. This next signal is WR bar, which is connected with the inverter to perform the write operation. Then 2 address signals A1 and A0 is available, which is connected to the control logic, mainly used to provide the port addresses for the 3 ports and control register. Next signal is reset signal, which is used to reset the control register value during the operation. CS bar is chip select signal, which is active low signal, which is connected to the inverter. Via the inverter, it is connected to read write control logic. When the signal is low, means the device will be ready to perform either read or write operation. Suppose the signal is high, even though we are applying another all signals are proper interfacing with the 8255, but proper interfacing with the 8085, we couldn't get the proper output. First we have to enable this CS, that is by applying low signal on this, the 8255 will be enabled, then we can interface it with the processor. Then as per our discussion, we have 3 ports. The 3 ports are divided as 2 groups, group A and group B. In group A, port A is available, in group B, port B is available. Actually both group have a 12 equal bits. So, the port C is divided as a 2 4-bit ports. So, one 4-bit is connected to the port A and group A, another one is connected with the group B. So, this is a group A signal. Group A consists of port A 8 pin signals along with the port C upper 4-bit signals. So, totally 12 pins are available, 4 pins from PC upper and 8 pins from port A. The another one is group B. In group B, it is a combination of port B along with the port C lower. It is 12 pins which are bidirectional. It can be performed for both input and output operations. So, in the functional diagram, mainly it has a data bus buffer, read write control logic along with group A and group B. In group A, it has a port A and port C upper. In group B, it has a port B and port C lower. So, totally 12 bits in each group for performing in and out operation. So, we have discussed 2 address lines are available, which is used to provide the port address for the 3 ports with control register. So, 2 address lines are available, which are connected to the decoder. So, 2 cross 4 decoder. So, automatically it provides the 4 output lines. So, among the 4 output lines, first 3 lines used for the port A, port B and port C, the last one is reserved for the control register. When both signals are low signal, then it will used for the port A. When the signal is port 0 1, it is a port B. When the signal is 1 0 means it will select the port C. Then both signals are high, then the control register or command register, both are same only. So, by using the 2 cross 4 decoder, by applying the various combination of A0 and A1, we can select our required port A, port B, port C and control register. Next one is control word. The control word is very important because it will define the in and out operations of 3 ports. So, control word, how we are defining the control word means the content of the control register is called as the control word. So, control register is a 8-bit content which is used to define the in and out function for 3 ports, port A, port B and port C. The 3 ports also operated in the 2 different modes, either IO mode or BSR mode. That mode selections also done in the control word. The IO mode have a 3 mode of operations which are denoted as mode 0, mode 1 and mode 2. In mode 0, this is called as a simple IO mode. In mode 1 is a handshake mode and mode 2 is bidirectional mode, which will be clearly discussed in the next slides. Group A is a combination of port A and upper ports of port C. In group B, the combination of port B with the lower ports of port C or lower 4 pins of port C. So, totally group A and group B have a 12 pins. So, this is a structure of a control word which is a 8-bit control word. So, the first D0 and D1, D2, these 3 is reserved for group B. D0 is reserved for port C, D1 for port B and D2 for mode selections, because only 1 bit is available. So, by the 1 bit position we can use the only 2 combination mode 0 and mode 1. So, group B will work only in the mode 0 and mode 1. In D0 and D1, when the bit position is 1 means it consider or it act as the input. When the bit position is 0, it act as the output port. The next 4 bit positions D3, D4, D5 and D6 is reserved for group A. D3 is connected with the port C upper, D4 is connected with the port A. When both signals port pins are 1 means it represents the input, when the signal is 0 it represents output, or when the position is set means it is a input, when the position is reset it is output. So, here 2 bit positions is reserved for mode selections, which is D5 and D6. So, when 2 bits means by the combination 2 power 2 4 ports we can select, but here we are using only the 3 ports. So, when the signals are 0 0 we will select the mode 0, when the signal is 0 1 we will select mode 1, when it is 1x, that is either 1 0 or 1 1 it will select the mode 2. The last bit which is D7 is very important, which will define the modes of operation in 8255. The 8255 will operate in the 2 modes, one is IO mode, another one is BSR mode. IO mode is simply all ports can be used as either input port or output port. In BSR mode it is only reserved for the port C. BSR is bit set or reset mode. When the bit position D7 is 1 means it will select the IO mode, when the bit position is 0 it will select the BSR mode. So, this is a control word format. First 3 bits reserved for group B, next 4 bits for group A, last bit for selection of IO mode. The mode of operation in 8255. The 8255 have a 2 modes of operation, one is IO mode, another one is BSR mode. In the IO mode it will define whether IO mode means it is a input output mode, which is used to define the input and output function of the 3 ports, port A, port B, port C. When the bit position is 1 means it represents as the input, when the bit position is 0 means it represents as the output. These 3 ports are grouped as 2 groups, group A and group B, which are worked under the 3 modes of operations, mode 0, mode 1 and mode 2. The another one is BSR mode. BSR means bit set and reset mode, which is used to set or reset the bit position of the port C. Any one of the bit positions we can set and reset by activating 1 and 0. So, now we will discuss the IO mode. This is the control word format for IO mode. In the IO mode the D7 should be 1, then remaining only 7 bits. The first 3 bits 0, 1, 2 is reserved for group B. When the bit position is 1, it is input, 0 means output, then only one bit is reserved. So, only 2 modes. Group B, it is used only in the 2 modes. Next 4 bits reserved for the group A. In the group A, D3 is reserved for port C upper, which is PC4 to PC7. When the bit D3 is 1 means the PC4 to PC7 is used as a input. The D4 is used for the port A. Suppose D4 value is 0 means port A is used for the output device. D5 and D6 is reserved for the 2 modes of operations, 2 bits. When the bit position is 0 0, it will be used for mode 0. When the bit position is 0 1, it is mode 1. 1 x, x represents it may be 0 or 1. Either you can use 1 0 or 1 1, it automatically select the mode 2. Group A will be used in the 3 modes. Group B is used only in the 2 modes. D7 should be 1 to represent the IO mode. So, in the IO mode, we have discussed the 3 modes of operations, mode 0, mode 1 and mode 2. The mode 0 is activated by applying the 0 0 value. This is called as a mode 0. This also named as simple IO mode. Simple IO mode means the 3 ports, port A, port B and port C can be used as simple input or output. Either it may be connected to the switches or any input devices. The output may be connected with the 7 segment display or printers. Based on our requirement, we can use this as simple IO modes. When the bit position of the corresponding bit is set means it represents the corresponding port is used as a input. When the bit position is reset, the corresponding port is used as a output port. The next one is mode 1. Mode 1 is activated by applying the value of 0 1 in M1 and M2. This is also named as a handshake mode. Here port A and port B, only 2 8-bit ports is used as either input or output. Port C is only for providing the handshake signals, or it is a supporting for port A and port B. So, for handshake signals for input and output, they are using the 3 signals. The 3 signals from each port C is provided, remaining 2 signals may be used as a IO ports. So, port C have a 8 signals. Among the 8, 3 bits for input, 3 bits for output, remaining 2 bits it can used as a simple IO modes. This is the function of mode 1. The another one is mode 2. Mode 2 is selected by using either 1 0 or 1 1. It will be used only in the group A. This is a bidirectional mode. Why we are named as bidirectional mode means only port A is used either as a input or output. We can apply for the both signals. In this mode 2, port B is not used. Port C is used for providing the handshake signal. Here bidirectional mode, input and output both we are using. So, totally 5 signals port C providing for the handshake signals. So, for input the port C providing the 3 handshake signals which are named as strobe, input buffer full and interrupt request signals. These 3 signals are interfaced from the input device to the microprocessor via the 8255. So, how these 3 signals will be used? So, now the 8255 is available with a empty buffer which is used to get the data from the input device. So, input device is connected with the strobe, input buffer full and INTR. Here we are considered as a port A, that is why I am written as A. So, when the input device send the data to the 8255, then the strobe signal will be enabled. Once the strobe is enabled means it represents it receiving the data. So, the buffer is filling. After filling the buffer, then it will intimate the input buffer is full to the input device. Then the input device will stop to send the data. Then 8255 activate the interrupt request. Once the interrupt request is enabled means it is connected to the processor. It means that now the processor have to read or take the data from the buffer. Then it will activate the read bar signal to read the data from the buffer. After reading that, the buffer will be empty, then the process will be repeated. So, during the input configurations, the 8255 is connected with the input device with the microprocessor. When the input device is ready to send the data, it will send the data or it feed the data to 8255 buffer. So, that time it will enable the SD bar signal which represents the strobe, the input is ready and also filling. After filling, it will intimate the input buffer activate the intimate buffer full signal, which is to intimate to stop the sending of data. Then it will activate the interrupt request to the processor to take the data from the buffer. Now, the buffer will be empty, then the 825 the input device again send the data. This process is repeated till the based on the available data. So, first it will activate STB, it will fill the data. After completing, it will activate the input buffer, then it will stop the process to send the data, then activate the INTR to interrupt the processor to take the data from the 8255 by activating the read bar signal. During the output configurations, they have a 3 signals, which is output buffer full, acknowledgement and interrupt request signals. The same thing, first once the buffer is full, now the processor send the data to the output device. Processor will write the data into the buffer. Once the buffer is full, then it will activate the output buffer full to the output device. The output device will read the data from the 8255. After taking, it will send the acknowledgement signal. Once acknowledgement signal is received, now the buffer is empty. So, the 8255 activate the interrupt request signal to the processor. Now, the processor will load the next data or new data. So, processor is connected with the 8255 to the output device. Here output device is available. In this output buffer full, acknowledgement and INTR, these 3 are the handshake signal for output configuration. Now, we are considering port A is output, that is why I have written as A. So, first the processor load the data to the buffer in 8255. So, for loading it activate the write bar signal. So, after filling or after completing the buffer size, it activate the output buffer full to the output device. Now, the output device read the data from the buffer. After it become empty, now it send the acknowledgement signal. Once the acknowledgement signal has received in 8255 means it represents the buffer is empty. So, it has to load the next data. So, now it activate the INTR signal. The INTR signal is connected to the processor. Now, the processor is interrupted to reload the or load the next data to 8255 for the next output data. Now, it will write the data. This is the output configuration. So, in the IO mode, it will operated in the either input configuration or output configuration. This will be suitable in mode 1 and mode 2. For in mode 1, it have a 3 handshake signals for input, which is strobe, input buffer full and INTR signal. For output configuration, it have output buffer full, acknowledgement and INTR signals. Next one is mode 2. Mode 2 is activated by applying the value of 10 or 11. This mode 2 is enabled only in the group A, which is a bidirectional mode. In the bidirectional mode, port A only used as bidirectional mode, it is the input and output configuration. Port B is not used, port C is used for providing the handshake signal. So, the combination of 6 signals here reduced as a 5 signal for handshaking, because the INTR is common for both the input configuration and output configuration. This mode 2 is mainly used for interfacing processor with the peripheral devices like a floppy disk or communication between the 2 computers. The 5 handshake signals are for the input configuration. What are the signals we have? Stop, input buffer full and INTR signals. So, we have taken only the stop and input buffer full. For output configuration, we have 2 signals, output buffer full and acknowledgement signal. So, finally, the interrupt signal, which is interrupt the processor to load or to read the data. The next one is BSR mode, which is a bit set and reset mode. The bit set and reset only for the port C. So, this is a 8-bit format. D7 should be 0, which is to indicate the BSR mode. D4 to D6 is not used, the 4 bits only for the function of BSR. The D0 is either set or reset. When the bit position is 1 means it will set the port C. If it is 0 means it will reset the port C. So, the D1 to D3 3 bit position is reserved, because we have 8 ports, 2 power 3 is 8. So, when the bit position is 0 0 means bit 0 in port C will be selected, 0 0 1 is bit 1 of port C. So, similarly, the PC 0 to PC 7 will be selected by writing the value of 0 0 0 to 1 1 1. So, this is the BSR mode. This is also 8-bit content. It is used to select, either set the corresponding bit position in port C, or you can reset by applying the value of 1 and 0. So, in today's session we have discussed the functional architecture, pin diagram of 8255, along with that the modes of operations. The modes of operation is very important, because when we want to interface the processor with the 8255, then we have to know how to activate the input and output in the ports. It have two modes, IO mode and BSR mode. Based on our applications, we can select any one of the mode and we can write the coding for interfacing. A question session: list the modes of operation in 8255, write the handshake signal and their functions if port A is used as input port in mode 1. Explain the functional diagram of 8255. Draw the pin diagram of 8255 and explain each signal in detail. List the modes in IO mode. Thank you.